once again welcome you all in this session from EduSoft regarding artificial intelligence talks. And today, as you know, we will talk about something very popular in artificial intelligence, that is regression or predictive analysis. We'll look at its simplicity and its application, and why do we use actually, if we are the part of data analysis or we are developing an AI project, how this regression helps us in dealing with the data which we have. So this we will look at. Some of you might have seen my other videos also, the previous two videos. The first video was just talking about with the new schools, how they should, what things they should keep in mind to implement AI course in their schools. So if you have missed that session, does not matter. It wasn't that important. The answer to the question is yes, you can implement AI. So the second session was talking more about basics of AI, the techniques and all that. Just a warm-up session to bring you into this series of talks. And now from this talk onwards, we will be focusing on specific topics. I don't know which topic will help you in which part of your classroom, but you will mix it up with your creativity also. And it does not matter that whether it is regression or is it computer vision or k-mean analysis, whatever. These are the algorithms. It does not matter in what sequence they are appearing in the curriculum. What you need to do is, whatever you learn from the sessions, you think of certain ways and you think certain activities around them so that you can involve the students into that activity in classroom or in field work. So that can be done irrespective of the sequence in which they are appearing in the course. So that is the idea here. So in the classroom, you can decide how you will teach the students. Book is there, of course. So like we talk about regression, regression has a lot of applications. So you can involve the students into a lot of activities. You can give them a small assignment, mini project, or a complete working project. A project does not mean that you give something at the end of the course. Project can be given at any point of time during the course. So you can create a mini project and you can assign it to the student. The student can develop that project parallel to the course going on. So this way you can involve the students more into practical activity. When we talk about regression, specifically linear regression. So when the word linear itself suggests that something continuous is happening. So if I have a series of data which is related values, for example, salary of past several months, or the marks of the students, or marks of a particular student across several tests in a subject. So these are the examples of some sequential values. Why sequential values? Because anything which you have to predict, if there is an astrologer, Jyotishi, if there is a Jyotishi or astrologer, he also needs the data, previous data, to predict your future. He looks at the Janam Kundli and all that, and he does some arithmetic. That arithmetic is what? It's an algorithm. He applies on the data which is there and predicts the future. Similarly, what happens is, in our linear regression, when we say linear, means a set of sequential values. They can be sorted, they can be unsorted, does not matter. But the values are sequential and they have some correlation. When we talk about linear regression, we come to another term, that is correlation. Correlation simply means how the data values relate together, how they are going to influence each other and how they are going to relate together. Now, in linear regression, what happens is we look at the sequence of data and then we try to forecast or predict the next possible value. So if I have a series of values 1, 2, 3, 4, 5, I can predict the next value would be 6. Even a child can do that with common sense. So, but what we needed is, to predict 6, we needed previous 5 values. So see, similarly, when you are trying to forecast something, you have to look at the data which is available to you, try to find out the relationship among the data values, and using that relationship logic, you try to figure what is the next value supposed to be. For example, height and weight is a very common example we give. In height and weight, either of them is available. If height is available, you can predict the weight in a standard scenario, in an ideal situation. So if a series of height is available to you, you can predict the next year's, next birthday, what will be the, or next height value, what will be the weight of the child or the person. So these are the certain examples where we try to predict. Weather data, we try to predict the weather depending on the values which are already available of previous years or previous months. So these are some examples. Now, when we talk about a series of values trying to predict the next value, this is one very simple scenario. The other scenario is causality. Causality, you have to understand. Causality means how one value is causing the change in another value. This is causal. For example, if a child, the marks, the performance of the child is depending on the IQ of the child. So IQ value of the child in a subject in mathematics, let's say, in mathematics, we are saying that, okay, child's marks are this much depending on the IQ of the child. The IQ of the child is 98, suppose, or X. So the marks are Y. The IQ of the child is changed. It is improved. The marks improved. So we are saying that IQ of the child is actually causing the improvement in the performance. Improvement in the IQ of the child is causing the improvement in the performance of the child. But that is one factor. For example, that child is very intelligent, his IQ is very good, but that child's concentration is very bad. So we do a psychological test on the students and you took out their concentration test, some values. Now those values we try to correlate with the performance of the student. And we found that many students who are of very high IQ are still not performing well because their concentration level is very low. So concentration level is another parameter which is defining, which is causing performance, which is affecting the performance. Fine. So these are certain things, these are certain factors which we have to consider. For example, weather prediction. In weather prediction, there are several factors. Not one factor will decide. Temperature, humidity, pressure, air pressure, and many other things are there. So weather scientists look at all those possible parameters. Similarly, to predict some value, we need to look at what all other parameters, what all other data values are going to cause this value. If we are not able to identify all the possible factors which are going to cause this value, our prediction will not be accurate. Are you getting my point? So it's not necessary that one X is going to define one Y. X, when I'm saying, it is those set of variables which are actually causing, which are actually affecting the other variable. So the variable data, the data set or the variable set which we are looking at to predict the value, this set of data is called predictors or independent variables, or you can simply say input variables, input parameters. And what we are trying to predict, what we are trying to forecast is output variable or dependent variable or predictable variable simply. So when we are looking at data X1, data X2, data X3, this is all independent variables. So concentration level, IQ of the child, we can bring in another parameter, for example, study habits, number of hours. So if a child's number of hours are very high, his IQ is very high and his concentration level is very high, that child's performance will also be very high in ideal situation. There is another fictional situation where we can think that due to some reason, the child did not write the exam properly. Then all the other three parameters cannot do anything. So in real life, things are very unpredictable. That's why linear regression is for forecast, but you cannot say confidently every time that this forecast is going to be okay. But out of several outcomes, if 95% are okay, correct, then it is acceptable. Very rare, in very rare cases, this happens that it does not work, but that's harmless. That percentage is very harmless. So there are so many parameters. So when we are talking about linear regression, simple linear regression, there is only one variable involved. With the help of one set of values, we are trying to predict the other value. When this number increases from 1 to 2 or more, that is simply called multiple regression. So this is what regression actually means. Now, where does regression help? We'll look into that. Well, when we talk about linear regression, as I was telling you, here you see a very perfect ideal situation, which is not possible in real life normally. You see there is a predictor or independent variable, X values are there 1, 2, 3, 4, 5. And Y is there plainly 11, 12, 13, 14, 15. It is a perfect correlation. As you see, linear regression can be visualized with a simple chart in Excel. You put one value on one axis, the other value on the other axis, and you draw a line between. This is called regression line or the best fit line. Now, this line goes through all the data values in such a manner that all the data values are at the least distance with this dotted line. Since this is a very perfect scenario, the line is going through all the data values. In real life scenario, this might not be there. The data values might be slightly away from the line. If they are too far, then they do not fit into the data set. So as much near they are the best values, they are best correlated values. Now, when we look at this chart, we have to get certain fundamentals out of it. One, if you look at the chart, somewhere it is written R square is equal to 1. So R square is actually correlation coefficient. It is showing correlation, and regression concept says that in correlation what happens is, if the correlation is between -1 and +1, then that correlation is the perfect correlation. If it is 0, if correlation is 0, then there is no correlation at all. I will show you practically also when there is no correlation in the data. Here you see the data is perfectly laid, a perfectly correlated data, so it is 1. And this is a positive correlation. Positive means the values are increasing positively. If the values are decreasing negatively in the opposite direction, then it is simply called negative correlation. Not much difference. So if in a negative correlation you find a value -1, so this -1 will be perfect correlation. +1 maximum is perfect correlation. Somewhere in between, the correlation either decreases or increases. 0, as the correlation value comes nearer to 0, the correlation in the data values decreases. So there has to be a balance. So what I mean to say here is, regression also helps you in exploring your data. When you are exploring the data to train the AI application, AI algorithm, regression helps you in finding out how the data is better correlated. And the better correlated data you can keep for the training. So regression helps you in identifying the quality of the correlation, the balance of the correlation in the data values. This is one advantage of regression. Got this? Coming to the next scenario. As you see here, this is another example where the values are not very perfect. You see, X is 1, 2, 3, 4, 5, of course, but the Y value is certain values which are given here like this. And look at the first data set. In the first data set, the prediction of the 6th value is done as 61. Now, how that prediction is possible? When we try to predict the value of any data in any data set, the next value of Y, depending on X, here X is actually causing Y. So 61 is predicted for value 6. That is quite obvious. But how did we do that? There are two aspects of this. If you look at the graph, you will see that this dotted line has a slope. This dotted line has a slope. This is one thing. And there is a distance between the data values and the dotted line. These are the two factors. The dotted line is called the slope, and the distance between them, that is called your intercept, or this is intercept coefficient, intercept value. So how do we do that? How do we apply the formula? This formula is given here. If you want to predict y, you have to take the intercept. You have to multiply the value of corresponding x with the slope, and you have to add them. So you take the intercept. Intercept is here. Intercept is given is here. 8.6, as you see in this value. Intercept is 8.6. Sorry, 17.2. Intercept is 17.2 given here, and 8.6 is given here in the is the slope of the line. Now that has come with the graph itself. When you prepare the graph in Excel, these two values will come automatically. So just by looking at the graph, you can analyze the regression values and you can do your prediction. And by applying this formula, you can predict the next value. You can forecast the next value for the predictor variable. So it is plain and simple. You prepare a graph and then you apply this formula. This is one very simple approach. So I will show you here. How do we do that? If I have prepared all this for you in Excel also, you see these sheets are there. So in Excel, the same thing is prepared here. R square is 1, a perfect correlation. Now, if I disturb this, if I do something like this, I'm going to change the data. See how the data is going to change. If I do something like this, 65, 3, 29, 4. Now you see these values have no correlation at all. They are not showing any trend or any increase or decrease. They are not showing any pattern. These are just random values. And did you notice what is the value of R? It is 0. 0 is showing that there is no correlation in between. So this data is not useful for training. So I just showed you how you can see whether the data is correlated or not. So this is one very simple way of looking at regression, linear regression. As we move further, we will look into more details. So as I told you that looking just at the graph, you can calculate, or what you can do is, if you are going to calculate regression by yourself, you have the formula given in the Excel itself. The other tools are also there. If I edit this formula, you have slope function already. So if you want to calculate the slope of the line of the data, slope in the data by a formula, you don't need any formula. You just pick up the function in Excel, that is slope function. Slope function, first of all, takes all the y values. B5 to B9 is the range of y values. And A5 to A9, the second parameter, is the range of all the x values, the predictor variables. So if you put it here and you get the slope. So it is giving me the slope 8.6. Similarly, if you want to calculate the intercept, you will again use intercept function, the same range you will give all the known y's and all the known x's, and you will get the intercept here. So once this slope and intercept are calculated, you can use them in the formula to predict the next value. See? So E3 is the intercept, which will remain constant across the formula for these values. 6 is the new value to be predicted. This is x, the new x, and multiplied with slope, E2. It is multiplied with the slope, and this calculation is giving you the possible value of next y, depending on x is equal to 6. So next y is 68.8, which is predicted here. So 68.8 will be the next prediction here. So this way, what we do is we try to predict the next value. Now, as you see, in real life, what happens, as I told you, forecast is, or predictions are not perfect. There are many factors which work. There are many unanticipated situations which occur, and that they affect the forecast by up to some degree. Now that is called errors or residual. Technical term is residual. You do not use this term with the students. That's just for your knowledge. You can simply say error or deviation from the actual prediction. So there are always errors. So what we have done is, these are the values which are available to us These are the values which are available to us in real life. If you try to predict, if you try to put this formula for each x, if x is equal to 1, then with this slope and intercept, I am trying to predict this y. So the actual prediction is coming 25.8. My actual data value is 29. So what is the difference between the two? 3.2. 3.2, this difference is the error. Now try to understand this. 29, 32, 41, 50, 63. These are the collected data values. This is the data acquired. Okay. And with this acquired data, with each value corresponding x, I am applying this formula, intercept plus x into slope. When I'm applying this formula with each y and each x, which is already available to me, I am getting some other prediction value different from the actual data. This difference is called error. So this error has to be always minimized. If you are able to minimize this error, your prediction will be more accurate. Lesser the error, more accuracy will be in the prediction. Now you see, when you are calculating the error, the difference between the actual predictions and the actual data value, this could be a negative value as well as a positive value also. So what you do is to eliminate the negative value. Whatever error you get, you take the square of it. A square of 3.2, a square of minus 2.4, and so on. So you take the square of all the error values. And with the square, after taking the square of all the other values, the idea is that you will get a positive value. You take the of all the squares, you total them. So if I take the square of all these errors and I total them, I will get 30.4 here. This 30.4 has to be minimized. It has to be as low as possible. So there has to be some algorithm which helps me minimize this error value, sum of the squares of all the errors which I have calculated. So if you are able to handle this, your prediction will be better. So this we have just seen. What is the role of intercept and slope in calculating linear regression? So if you know this formula, you can easily, slope function, intercept function, you can easily predict the next value. Nothing else you need to learn as far as basic linear regression model is concerned. But let us look at many other aspects. For example, what are the application areas? Now you can think of many of them. With your, if you're already teaching artificial intelligence and you have taken this topic, you already know there are so many areas where X variables and Y variables are available, and you can do so. Like age and height is a very common example. Experience relates to salary, employment index, and hunger index. Poverty relates to crime rate in a particular area, and so on. So these are certain applications. Rainfall. Due to rainfall, how the production of a factory or a production unit is affected. One example, how production and budget, how you will predict the budget for the next, or the cost for the next production. This can be done looking at the production values, demand and sale, sanitary conditions of a hospital, and the medical cases in sanitary conditions in an area, and medical cases there, number of patients coming from there. Then test score and test scores and final exam score, inflation and revenue, product price and product features are related, air quality index and air pollution parameters, they are related. So these are certain examples which I could think of. With your experience in reading, you can add more to it. So these are, as you look at these examples, you can see that in every industry, in almost every area, the scope of linear regression is always there. And that's why it is very popular, because first thing is it's very simple and very, straightforward. You don't have to mug up much of your mind, and it's very powerful. Despite being simple, it looks very simple. Okay, you multiply something with something and you get some value. What's special in this? But what output you get is very important in forecasting something. You ask a businessman, you ask a statistician, you ask a mathematician, or somebody who is involved in predicting, in taking a strategic decision. They will tell you the importance of linear regression. Linear regression helps you in taking informed decisions. That is very much important. Linear regression for a data scientist, if you are collecting the data and giving it to an AI algorithm, linear regression is very important for you to find out the distribution of the data, how data correlates well, and which data values you have to discard, which data values you have to keep for the algorithm, because better correlation will minimize bias, better correlation with minimize noise, and a good correlated data will help the AI application learn in a better way and predict in a better way. So this is the importance of regression. Coming to my Excel sheet. Well, we have seen this, how to calculate the regression. Now, there are other means of calculating regression also. Let us look at it. Let us look at one very perfect scenario here. All good win-win situation. In real life, that does not happen. I just showed you, even if you specify one value which is out of the way, your entire regression has gone down to 0. Your R square has gone to, the correlation has gone to 0.3. And a good correlation has to be somewhere near 1 or -1. If it is negative regression, then it is -1, otherwise 1. So 0.3 is quite far from 1. So a good correlation is your 0.8, 0.7. This is a good value. So here it is 0.9, a perfect scenario. Now, if you look at this data, there is another way. For example, instead of calculating slope and this like this, if I have certain values, now the question is, how do we go for what slope value or what intercept value will help me? So one way is you prepare a chart and you get these two automatically. Another thing is that we try to do random, but random calculations doing a lot of data is going to waste a lot of time. So suppose I have some random values 12 and 25 here. So how am I sure that this 97 prediction is going to be good? How am I sure that my slope and intercept I have taken perfectly well? And you see the sum of squared errors, it is 1766. So it's a lot of error values here. You see the actual data which I had, Y data is 29. And when I performed this intercept plus X into slope, when I did this, I got 37. It's a big error here. So how do I minimize the errors? One very good tool you have available is Solver. You might not have heard about Solver in Excel. So what you do is you go to File, Options. In File, Options, Add-ins. Solver is an add-in. It's an additional functionality. So you will go into add-ins and you will see Analysis Tool Pack. In Analysis Tool Pack, you will, you can go for Solver add-in directly here. It's visible here. It can be it is the part of this tool pack also, or if you just need Solver, you can select Solver add-in and click on OK. So when you do that, in your data ribbon, you will get this analysis group and you will see this Solver over here. Your Solver tool is visible here. Solver can be used, it applies an algorithm to minimize your error. It is actually used for maximizing values, minimizing values, or reaching a particular value. Let us see how does it work in our case. So you click on Solver, the Solver box opens. Solver needs two things from you. One is, what do you want to minimize? What do you want to set? What do you want to minimize here is the sum of squared errors. This error value you have to minimize. So what you do is here you select the error value, which is in G2. I had already done this practice, so it is already showing those cell addresses. But G2 is this is what you want to minimize. And what are the inputs for that? What are the changing cells? Slope and intercept. So slope and intercept, this you want to change. So here I select these two. So what did I do in the Solver? I told the Solver what I want to minimize here, the yellow cell, and what I want to change, slope and intercept, these values which I was earlier taking randomly. And now when I click on solve, see here it is showing make unconstrained variable non-negative. This tick mark, you should remove it and you click on solve. As you click on solve, solver will show you the possible values. Did you notice 8.6 and 17.2 has come? It was earlier also. That was due to solver. So if you want to keep these values, you click on OK. So as you click on OK, these values are kept here and your error is minimized so much. It was in thousands earlier, now it is 30. So this is the perfect value which is for slope and intercept which solver has given you. You did not have to put any formula or anything and solver has done it for you. Earlier you were able to do it with slope and intercept. See the same values 8.6, 17.2. This is coming with slope function and intercept function. So what slope function and intercept functions are doing here, the same thing can be achieved by solver. So it's up to you which tool you want to use. So all this, what you can do in classroom now, when you're taking linear regression in classroom, what you can do is you can teach students, first of all, how to prepare charts in Excel. And when they're coming in class 8, they might already be knowing about it because they are learning computers beforehand. So many of the students will be able to make chart in Excel. So you show them how, you show them this regression thing by brushing up their chart Excel thing first. So you revise, you take a session on how to prepare charts in Excel, and then you show them this. So with this practical thing, you can explain regression in a better way to the students. Now, if you're talking about artificial intelligence in general sense in the classroom, you can say class machine learning or artificial intelligence does not mean that a robot is playing football with you. That is one application, but that is not actually artificial intelligence. Artificial intelligence is enabling a machine to look at the data and predict something. That is one application, one use. And for prediction, we use linear regression. So if I'm able to burn this formula into an algorithm, AI algorithm, whatever data it gets, it will be able to predict the next values. That is one simple example of artificial intelligence. So last I talked earlier, like I talked earlier in my sessions, that if a digital clock is looking at your sleeping habits and your getting up habits, at what time you sleep and at what time you get up, that digital clock can predict after 10 days, at what time will you get up. So this is one thing which can be done with linear regression. So you have to clear the student's mind that artificial intelligence is not that making a machine behave like human. No, it's not going to behave like human, but some human-like outputs it can give. It can work in a human-like fashion. It's not processing the data. It is looking at the data and doing some prediction. And in between, a linear regression function is working. That is one example. So this way you can explain. So we have seen regression with very simple example. If we try to apply it in a real life, for example, this. Now, after explaining the concept, you can show them a real life experience, or you can give them an activity to collect some real life data and do it themselves. For example, this is one scenario where a company is looking at the previous data, the display of the ads on social media. So when they displayed 600 exposure of the ad, they got 1,000 visitors and so on. You look at the data values are not much correlated, but still correlation is 0.8. So that's a good distribution. And now they are planning, if they show 1,000 ads, if they display 1,000, if they go for 1,000 exposure of ads, how much visitors should they expect? So expectation is 1,775, almost 1,500 visitors should be coming to their website if they are going to display the ad 1,000 times. When I say 1,000 times, it is 1,000 times to different persons. An ad can be displayed to one person multiple times, that will be counted as one. So if 1,000 times it is going to be displayed, then so many visitors would come. So this way, They are trying to predict how many visitors will come with exposure. And here it is. Here the data given, the dotted line is given, the chart is prepared. Rest of the things are same. Intercept formula is there, slope formula is there, and prediction is done by intercept plus x into slope. That's it. And here you can give them how do they do it with solver. So you can ask them to apply solver here and minimize the values, minimize the error. And then they can calculate the prediction. So this is how your solver will work. This is how you can do it with the formula, intercept and slope. Now we look at some data analysis here with two set of values, 1, 2, 3, 4, 5, and y is these values, 29, 32, 41, 50, 63. With these values, a lot of data analysis has been done here. It's quite mind-boggling, don't worry. We will only look at the values which are useful for us. One is R square. We are familiar with this. R square is always showing the correlation between the data values. 0.9 is a very good correlation. If you look at intercept and X, 17.2, 8.6, this is also visible here. Prediction value. Now X is being used to predict Y here. But how good is X for predicting Y? This can be calculated here. P value means prediction value. How I got all these values, I will show you. So prediction value is 0.0 here. It's a very perfect prediction value. Always remember, prediction value has to be less than 0.05. Please make a note. Prediction value of an predictor variable should be less than 0.05. If it is going for a value, if the prediction value is going higher, 0.05 or above, you leave out that parameter. For example, if you are predicting salaries for employees, now salary has nothing to do with gender. No matter what is the gender, it will depend on the experience and the qualification and the performance of the employee. So experience, previous performance, these two parameters are very strong and they will help in predicting the salary of the person. But gender is not going to predict. You are a male or a female will not decide how much salary you will get. That is bias, social bias. So gender is not going to predict the salary. Salary is the Y variable. Gender is one of the X. So here it's a I'm taking an example of multiple linear regression where there are 3X: experience, performance of the employee, experience of the employee, and gender of the employee. But you will see the gender of the employee, the P value will be very high. It will be more than 0.05. And if it is more than 0.05, you completely remove it from your data set. That parameter is not useful for predicting your salary. So this way, this data analysis will always help you in deciding, especially in multiple linear regression, where multiple parameters, many X's are there, which X's you should keep and which X's you should exclude. So the X's which are showing the P value 0.0, 0.1, 0.01, like this, those you keep, others you discard. So this data analysis is showing me other things also. What are the predicted Y's? What are the errors? I told you residual are actually another name for errors. What are the errors? So all these are in a single sheet. You can do this data analysis. You can even have an automatic chart where it is showing that predicted Y and actual Y are very close to each other. So this prediction is perfect. So this is a perfect situation data analysis. How I came to this sheet, how I prepared this sheet, I will just show you. Just like solver, you have another add-in data analysis. You go to file options and you can add this data analysis here. And when you click on data analysis, it will give you so many tools. When I click on data analysis, it will give me so many tools. From these tools, I can look for regression. Here it is, regression. And when I click on OK, the regression dialog box is coming up over here. In regression dialog box, I will select input Y range. Where are my Y variables? My Y variables are here. I am selecting this. My Y variables. Where are my X variables? They are here. My X variables. Do I want to label the data? You can click on label to label the data. Where do I want to output the analysis? The output of the analysis can be put onto a new worksheet, or it can be put on the same sheet from the cell which you want. So I have done this. I selected this cell, and when I will click on OK, this entire sheet will be generated. See, the entire sheet is generated. I show you again data analysis, regression dialog box. I just mentioned where are my Y's, where are my X's, what output range, where I want to have the output. And one more thing, you can see the charts, what charts you want to see. So you can say, I want to see the line fit plot, residual plot. You can also display the plot which is showing the errors. So it's not necessary here. Line fit plot will give you this graph. So all this can be done in a jiffy. In a second, you can do that. And see, this sheet is generated. A fresh sheet is generated. Our point of interest is regression, R square, sorry. So I highlight this R square. Our point of interest are these two. So this way, I can go for data analysis. Data analysis. Yes, ma'am.
So this is also another add-in, or it is a tool which is like solver we added. So this is already there.
This is also an add-in. You can do it same way. You go to file, options. In options, you will go to add-ins. In add-ins, you will see analysis tool pack.
Okay, fine. So both need solver and fine, sir. Fine. It's okay, sir.
I just show you analysis tool pack. Then at the bottom, you don't click on OK. You click on go. Click on go button. In go button, I have already added solver and analysis tool pack here.
Okay, sir.
Now, when you click on OK, this analysis tool pack will be added to your data.
Fine, sir. Yeah. So these are basically add-ins which need to be added. Okay,
so it is just to save you time. Whatever you do manually calculations, it will save you time. It will help you analyze your data. Now, this is how actually data analysts perform the data exploration. So if you find for any parameter p-value is very low, you decide that you remove it. If p-value is good, you keep it. And you see the correlation here. If correlation is 0.9, then you can say, okay, whatever data I have, it is very well correlated. So you can decide on the quality of the data, which is going for an AI algorithm. So this is more of a tool. Regression is this data analysis tool is actually more of data exploration. So without making any charts and all, in half a second, you get all this data and you can just decide what data to keep, what data not to keep. So I just showed you because that's an interesting tool, and this will help you in your classroom sessions also. You can explain using this tool, you can explain how to look at the data. So basically what you have to teach your students how to look at the data and try to find out what kind of story the data is trying to tell. What are the trends? Is the data correlated? In case of linear regression, you have to determine whether the data is well correlated or not. So this is another aspect. So we were talking about linear regression. Whatever examples you saw, those were simple single variable examples. There is multiple regression when more than one variables are involved. So what we are trying to do here is the price of any commodity, for example, vegetable. We are trying to predict the price of vegetable by looking at the historical data. The previous prices are here, and we are considering two factors here: the oil prices, the fuel prices, and the rain, how much rain happens. So you might have heard that due to drought or due to flood, the agriculture is affected and prices go up. अच्छी बारिश हुई, prices stabilize. So rain is a deciding factor in the price of a commodity, especially vegetables. And oil price is also a deciding factor. So we have taken these two variables here, and the rest of the things are pretty same. Now, there are two x's involved: oil price and rain. These are x, I'll call it x1, and this is x2. And this is my y, which I try to predict for next value. So if I have oil prices like this, all prices, mostly they increase, they hardly decrease. So you see, oil prices are increasing in a sequence. The correlation is there. With common sense, we can figure it's a very small value. In case of artificial intelligence project, in real value, there will be thousands of values. So just by looking at, you cannot find the correlation. R square will be needed. So you go for data analysis tool for that, or you prepare a graph. Now, graph has a limitation. For 1,000 values, preparing a graph is very cumbersome. So you better go for data analysis tool. And we are trying to predict 92. If the oil price will be 92 and rain is somewhat normal, so what will be the price of the vegetable? So here it is calculated as 55.76. How it is done? Now, if you remember, intercept is only 1. And we add the intercept. You remember the formula: intercept plus x multiplied by slope. This is what we do in simple linear regression, single variable. But there are x1 and x2. When there are x1 and x2, what we do is we keep adding them. x2 into slope, x1 into slope. So as many x's are there, you just multiplying them with their slope and keep adding them into the formula. That's the only difference between linear and multiple regression. But the point is, as many x's are there, for every set of x, there is a different slope. x1 has a different slope, x2 will have a different slope, and so on. So if you have 10 parameters, there must be 10 slopes. How do we calculate that? So you can apply slope formula separately. You can say slope function, known y, and oil price. This will give you the slope of oil price. Then you go for slope of rain. You will say price values again, and the rain values. This will give you the slope function. The slope function will return the slope for rain. So either you do it manually for each of the parameters. In real life, there could be 20 parameters. So you do it 20 times. Or what you do, I am showing you another interesting function here. That function is linest function. I'll just show you. Linest function will always give you all the slopes and intercept. Now, this is a very special function. Generally in Excel, we have learned that a function returns a single value, but linest function is an array function. Array function is a function which returns more than one value. So linest function is, in this case, is going to give you 3 values: the intercept, slope of oil, and slope of rain. So here I go. In linest function, I will put in all the y's first of all. The first parameter goes is all the y's. Then I put a comma. Then second parameter, you don't have to do it one by one. You just select all the x's together. Please make sure in your data sheet, all the x's should be together so that you can easily select them as a single range. So I have selected oil price and rain together like this. I have left out the labels, only the data values. And then I close the bracket. Now, if I press enter, this will not do. What I have to do is I have to press Control Shift Enter. Control Shift Enter will give me 3 values. That is why whenever you are going to use linest function, you always select as many cells in which you want the values. In our case, I want 3 values: intercept, oil price slope, rain slope. So I have selected 3 cells. After selecting 3 cells, I type the formula. All Y's, X ranges. So first step is select as many cells, as many values you want from line list. Type line list formula, and then you press Control Shift Enter. Do not press Enter, you press Control Shift Enter. Control Shift Enter will give you. Now pay attention here, it's very, very important. Otherwise you will goof up in classroom. The rightmost value is your intercept. यहां थोड़ा सा रिवर्स में हो रहा है क्योंकि हमारा डेटा लेफ्ट टू राइट है. Linest is giving the first value as intercept. Always remember. Second value is first X. Please remember, second value is starting from right to left. And the third value is X2. That's why you see in our data, oil is coming first, rain is second. But when I'm calculating these, rain is first, oil is second, because here you have to move from right to left. So this is your oil is coming, slope of oil, then slope of rain. So please remember this. Remember right to left in Linest function. And you see 0.02 is here, 0.4 is here, 14.06 is here. So this is what I got from Linest function. And then you apply the formula. See, intercept is in F2. A10 is the new value of oil price into slope of oil. Slope of oil is in E2 plus B10. B10 is your X2, the new value of rainfall measurement, multiplied by slope of rain. Slope of rain is in D2. So whatever concept is there, you have converted into Excel formula, and you have used this function, and this is the prediction. So oil price will be 55.7 if this much, price will be 55.7 of the vegetable if oil price goes up to 92 and rain remains normal. So this is one real life scenario where you are using this Linest function, which is an array function. Well, friends, how did you find this? Interesting or mind-boggling?
Sir, let me give my feedback first. Honestly, I had a phobia. I've been teaching artificial intelligence since last 2-3 years for class 10th only. And because linear regression means it's statistic, and I'm not very good into it. Though I've been surfing on net, thoda samajh mein aa jata. But honestly, aaj mera phobia khatam ho gaya, sir.
Oh,
but yes, thank you so much.
Linear regression we have understood. We have seen multiple linear regression also with an example. What you have to do is you have to think of more examples. If you research internet, you will get examples of linear regression. In your school itself, there are so many. I gave you one example of concentration of the child and IQ of the child. That gives you a multiple linear regression example. There are many around. So what you do is you make a list of it, and out of that list, you can give project to the students. You can give field work to the students to work on linear regression and present their model in the classroom and do forecast. And you can give them a value, and first hand they show you how they forecast it in the classroom itself. So that will be very interesting for the children. With your creativity, you can make it interesting. This is one thing. Second thing is you can give them a survey task in the classroom itself. If you don't want them to move out into the field, time is less, they can do a survey in the school itself. For example, the popular ice cream, after popular ice cream or chocolate, they can survey with the students. The students eat ice cream, chocolate, and fast food, burger and all. And then you can predict, okay, which is the most popular, what is this student is going to buy next, or how much that student will pay for a burger. If that student is very good at, if that student's burger is favorite for the student. So these kind of survey can be done by the students in the school itself. Survey data can be used as X variable and Y variable, and then they can use it to predict next Y. So these kind of things, with little research, you can create many activities for the students. Somebody was asking, like, how this correlation has to be, how are we so sure that correlation is good? So let us see, how do we do that? The sheet which is in front of you, please do not be intimidated by it. We will intercept it one by one, and then we will come to the conclusion. There is something called correlation coefficient, or it is denoted by R. You have seen R square, I told you about. That is the correlation coefficient. In this perfect data, 1, 2, 3, 4, 5, 11, 12, 13, 14, 15, perfect correlation. So my R is coming perfect 1. You can see in the graph also and in the calculation also. But things are not so rosy in real life. If I disturb this data, if I make it 2000, you see entire correlation has gone haywire. So how do we do that? It is a game of sum and product. Let us see how do we do that. Look at the data. My predictor variable X is there. My predicted variable Y is there. First of all, you multiply them. You take the multiplication of all these in one column. Then you also calculate the square of X values and the square of Y values. Do that. If this much is done, then all the calculation can be done. So what you have done, you have multiplied them in one column, X and Y multiplied. Square of X's you have taken, square of Y's you have taken. These are the inputs you need. And number of values is 5. N is 5 here. 1, 2, 3, 4, 5 observations are there. 5 cases are there. 5 data values are there. Now you look at this formula. First of all, what we move in a stepwise manner. First of all, we go and multiply number of values. We multiply with the sum of the product of X, Y. That means this sum. What is the sum? 205. You see here the formula. 5 is the value of N. 5 into sum of product of XY. Where is the sum of product of XY? Here. We have already taken the product. Sum is here. So you just put it there. Minus sum of X into sum of Y. जितना भी Y का sum है और जितना X का sum है, इनका multiplication. What it is? 15 and 65. So you have taken N multiplied by sum of the product of XY minus sum of X multiplied by sum of Y. First of all, this is first step. You calculate this value. Whatever it comes, you keep it here. You see the same formula I have applied. Then you go for next step. Number of values into sum of squares of X. That is 55 here. Sum of squares of X minus squares of sum of X. Now you try to understand this. Sum of squares of X is you take all the squares and total them together. You take all the squares first and then you take the total. That is your sum of squares of X. And you minus what? Square of sum of X. So you total all the X and you make its square. That is total all the X, that is 15, and you take the square of 15, 15 into 15. So what will come here? C9 into C9. You see 15 is C9. C9 multiplied by C9. So first step is done. Number of values into sum of product of XY minus sum of X into sum of Y. This is first step. Second step is you calculate number of values into sum of squares of X minus square of sum of X. Whatever comes, keep it here. The same thing you do in the third step, the same thing you do with Y. Number of values into sum of squares of Y minus square of sum of y. These three steps are done and you have certain values here. Now what you do is you consider step second and third. Step second and third, you take these values and you multiply them. Multiply these two values of second and third step, you will get another value here. I have multiplied I13 and I14 and I got some value here in I15, 2500. Whatever value you get here, you take the square root of it. Square root of it, and whatever comes, you keep it here. So you have taken the square root of these two steps, multiplied, and you took the square root. And then last step, what you do is whatever value you had got in first step and the square root, perform a division between the two. Perform a division between the two, and whatever you get is your R square or correlation coefficient. If it is 1, it is a real, it's a dream situation, not a real life scenario. In real life scenario, let us see. If I say 11, let the 11 be there. Then I say 14, then I say 12, and I say 20, and I say 13.5. So you see my correlation coefficient is 0.4. It is a poor correlation. Graph is also showing that there is no correlation at all. It's a poor correlation. So you better bring in more data so that this correlation can be made better, or you clean the data, or there may be more noise in the data. You remove unnecessary data. So all these things you have to do. This is the part of data exploration here. So I bring it back. So this is how you calculate your correlation. I just show you how does it look like. It looks very scary here. Whatever steps I told you, they are here. This is the formula I was discussing with you to calculate correlation coefficient. Now it is your choice. You go with this formula, or you pick up the data analysis tool, or you make a graph. It's your choice. So if you want to spend some good time with the students in the classroom, you want to take more sessions on linear regression, you can go for correlation coefficient. Correlation coefficient will always tell you how good is your data. That was the first step. You see above the line, this is the first step. This was the second step. And this is the third step. I broke down it into 3 steps. See the first step, I got 50. The second step, again, I got 50. And whatever is come here, I have taken the square root finally. And finally this. Whatever I showed you in the Excel sheet is shown here in the presentation in a stepwise manner. And finally, I performed this entire thing, entire formula here, and I get the correlation. Whatever value comes depends on your XY value. So don't worry about that. You just have to see, okay, if this is far from 1, you have to think about the quality of the data. I will give you this presentation. I will give you this Excel sheet so that you don't have to do anything. You just change the values, you change the example, and you can use this sheet again and again in the classroom.
Sir, needed all of them. Your recording, your presentation, and your
everything you will get in a single package. I will mail you all. When you fill the feedback form, I get your email ID. In email ID, you'll get everything along with your certificate.
Okay, thank you so much, sir.
Another thing is, many times what happens in real life, as I told you, things are not that rosy in real life. You collect the data, you do a small survey in the school, and you will see for yourself. The data is very difficult to correlate. So it's very important that we see the distribution of the data, how the data is distributed. Now, a very good correlated data is always found closer to the average of the values. So you have taken the survey of some kind in the school, and you have got a collection of a set of values, say 100 values. First thing you do is you take the average of those values, and then you analyze how many values in the data set are closer to that average. More closer they are, better is the data. Farther they are, irrelevant they are. And how you can do now with 100 values, you cannot do it manually. There are two ways. One is you go for a graph. What you do is whatever data you have, suppose I have collected this data. You see here, I have collected this data. And on this data, I simply go insert charts. In the charts in Excel itself, you will see one chart, box and whisker. Box and whisker chart you select, and the chart will come like this. And you see, just by looking at this chart, all the values are very closer. So this data set is very normalized. This data set is well distributed and perfect for training of the AI algorithm. If I disturb any one value, see here, instead of 600, I make it 2000. As I make it 2000, you can clearly see in the graph that this value is irrelevant, falling very far from other values. Such a value is called outlier. Outlier does not fit into a data set. Outlier can create noise. Outlier can make your calculations just go for a toss. So you get rid of outlier. So outlier has to be removed. Just by box whisker, you can figure it.
So this is what we teach the student. This is like overfitting when you're trying to train the machine with all the possible values.
Yes. I'm coming to it.
Okay.
First of all, we see the distribution. So this is one way. Manual way of doing is to calculate standard deviation. Lower the standard deviation, better are the data values. How do we do that? First step is whatever data you have, you take the average of that. The average 580 has come here. Now with this average, you take the difference of each of the data value. 600 minus 580, 700 minus 580, 500 minus 580, and here it is. You get some values. That is data value minus the average of all the data values. Some of them might be negative. To get rid of the negative, you take the squares of them. And when you take the squares of them, what you get is actually called variance. And then simply, if you take the square root of the variance, you get the standard deviation. See, standard deviation is very low, 74. The values are in hundreds and the standard deviation is in 74. It's a pretty good set of data, very well correlated, very well distributed. If I make one of the values very high, you see the standard deviation is in hundreds. So this way, by looking at the standard deviation, you can take a guesswork, okay, this data is good, this is not good. By looking at the whisker chart, you can find out the outliers and remove them. This way, you can decide the quality of the data. One aspect. Other aspect is sometimes what happens, as ma'am told us, something called overfitting or underfitting. Now, when the data is very well correlated, we are very happy with the data. Okay, this is the perfect data I'm going to for linear regression. Sometimes what happens, there are certain values which are irrelevant. If you mix up irrelevant values in your data set, it will still show very well distribution, but prediction will be affected. That's why I told you that I analyze the prediction value. For each parameter, you go for the prediction value. Prediction value, if it is less than 0.5, the data, that parameter has to be kept. Otherwise, it should be discarded. So you have to be very careful. Data should not overfit. Overfitting means a pretty good data, a very good data mixed with noise. The noise values are also like actual data. The irrelevant, what is noise? The irrelevant data. Irrelevant data is mixed with your relevant data and it is giving you a very good prediction. Hypothetically, but in real life, the machine will fail. So in training, the machine is doing very well. And when you deploy it in the real, when you evaluate it, when you give it the real life data, the predictions are not going correct. That means that your data which you use for training had irrelevant data mixed in. And overfitting means two good values for training. So correlation has to have some balance. It should not be very perfect one. Somewhere between 0.6, 0.7 will give you a better figure. And similarly, underfitting. Underfitting means your data set has not much rich proper values of the data, and the AI algorithm is not giving correct results in training itself. So with a data set with which you are not able to train the algorithm, such data values are called underfitting values. They have to be corrected. The values which are used for training the data, training the AI algorithm, and AI algorithm is performing very well during training, but it is failing in real life scenario. In testing, it is failing. Training data set, perfect. Testing data set, result is failing. So that is overfitting. That data also has to be corrected. So these are the tasks of data analysts which ensure that proper data should be fed to the AI algorithm for training. So I hope you got this idea of the use of standard deviation. This you can do with your results also. Whether the students are performing well, all the students are performing well or not, you can do this standard deviation. Instead of average, actually the standard deviation of the teacher should be calculated for performance. So once again, thank you all of you for being present here on this Sunday.